Hi guys, welcome back to Tronic Synergy, where we do fun stuff all day, all time. Today we are going to begin a new series on multiplexers. Previously we've done in our logic circuits, we have done half adder, full adder, half subtractor, full subtractor. We have done different kinds of flip-flop. We did SR, set and reset flip-flop. We have done data latch or D flip-flop. And I'm yet to do JK flip-flop, but I'm going to do it in my couple of next videos. So today we are going to begin with multiplexers. We say that we are moving on in order to see if we can make a functional ALU. So for a multiplexer, we are going to begin with a 2x1 max or a 2x1 multiplexer circuit. What a 2x1 multiplexer circuit means is that it has two inputs and one output. Next, maybe we are going to do a 4x1 multiplexer, and we can move on doing even 8x1 multiplexer, but that requires a lot of logic gates which might fill up my breadboard. So for me to go to 8x1 multiplexer, I need another breadboard for me to demonstrate that. So today we are going to do a 2x1 multiplexer, and multiplexer simply is a circuit that selects the input that you want to be shown at the output. So if this is a block diagram representation of the max or the multiplexer and what it does internally. So if I'm having input A and B, this S is the selector and P is the output. So if S becomes 0, it means that this P will go straight to A. So S naught will be A, and S1, if S will be 1, then it's going to select B. So that's basically what the multiplexer does. It can choose couple of inputs. Even for example, for a 4x1, it has 4 inputs, A, B, C, and D, and has two select inputs. So when we get there, we're going to see what or how to connect a 4x1. But for today, we are doing a 2x1 multiplexer for us to understand the basics of the multiplexer. So this is the symbol of the multiplexer. Has two inputs, has another select, and one output. So for my circuit down here, you can see I've added another input called the enable input. This is not it's not important, but you can put it. Not all multiplexers have enable input, but most of them do have enable. So what it means that enable, if the enable is on, it's when you can now start doing the select and everything. But if enable is 0, meaning that these AND gates will just give a 0 and you will get a 0 output. So the enable has to be on for you to do your selecting and for you to do your functions in the logic gate. So that's basically what the enable is. Not pretty hard. It just enables the circuits and also disenables the circuits. So you can look at it as a switch. If it's on, it's when you can do your stuff, and if it's off, nothing will happen, and your output will be off as well. So my input is right here, A. So for this first AND gate, it has input A. It has in S inverted. This is the select inverted because of the NOT gate, and also has the enable as the other input. So the output of this first AND gate can be represented in this Boolean expression. It can be A dot S inverted or S complement dot E, which is the enable. So that's the expression, or that's that's what the output will be representing. Then AND gate B, the AND gate B, it has inputs as enable, S, and B. So this output can be written as enable, then the middle one has S, then the other one is B. You can just mix or you can start with B, E, S, or how you want it to be. So then those two outputs of those two AND gates enter an OR gate, and once they enter an OR gate, the output becomes this first one, which is S complement enable plus showing, sorry for that, let me just start it all over. So it's A dot S complement, then enable, then OR the enable S, then B input. So simply to explain this, when this S is 0, meaning that when S is 0, meaning that this will be on. This will be on. And for those who are new to logic gates, an AND gate operates in a way that all inputs have to be on for it to give a 1 output. So if this is 0, meaning definitely that this is off, meaning that it selects the A, the AND gate having the A input. So if this is 0, then it's going to be inverted to be 1, and when it's 1 and A is 1, and also the enable has to be on, then it's going to give you a 1 output, which will be shown by lighting up this LED, meaning that input A is on. Then when S is 0, or when S is 1, meaning that when it's being inverted it will be 0, meaning that this will be cancelled. Now we'll be dealing with the AND gate B. So if it's 1, enable is on and B is on, then it means that the B input will be shown here as on. If B was to be 0, this is 1 and this is 1, then it's going to be 0, meaning that the input B is 0 being showed here. So that's how the multiplexer selects between input A and input B. Yes, so let me demonstrate this on a breadboard for you to understand. So my circuit is right here, and my circuit is right here. So this is basically the connections of the 2x1 or 2-to-1 max circuit. I have my input section right here containing four deep switches, and I'm using all of them. The first one is A, the first switch. I'll use it as A. Second switch will be used as B. Third switch will be the select, and the fourth switch will be the enable input. So the enable has to be on at all times for me to operate the max, the multiplexer circuit. So the logic gates are right here. Logic gates, the AND gate, the OR gate, and the NOT gate right there. And the connections are just the same as the schematic right here. Then the output is a green LED, and yes, the inputs are right here. So this first LED, blue to show, those two blues show the input A and B. Green shows the select, and orange shows the enable input. So I'll go ahead and light this up. Let me just put all inputs 0. Yes. Then I'll go ahead and start this. I'm using a 5-volt power supply, and it's on. So once it's on, you can see that everything is off. All my inputs are off because the enable is off. So everything will be off because the S will be inverted to be 1, but because the enable is off, meaning that no AND gate will be on. So that's why the circuit looks like that. So let's start with this. So if I put a 1 input at this section, if I put a 1, then I enable. So first of all, I have to enable my circuit. Let me enable pin number 4. So I've enabled my circuit and it's on, so meaning I can do other operations. So let me start by putting A on, then I select it. So if select is 0, meaning that I'm choosing this first AND gate. So if I put A on, then the output will be on. So Let me put A on, and once it's on, the output is on, showing us that A is on. The select is 0, meaning that we are choosing this AND gate. If it's 0, it's going to be inverted to be 1. Then the enable is 1, so it's going to show as 1, meaning that A is on. So let's turn off A and see what we are going to get. If I turn off A, still I've selected this AND gate because S is 0, meaning that it's going to be on here. But A is off, so the output is showing that you have selected A, input A, but A is off. That's why the LED is off. Yes, so let's do that to B. Now let's go to B. Then I put on B. Now I put on B, but select is 0, meaning that nothing is happening because select is 0, meaning that this point will be 0. Of course, this will give us 0. So we have to we have to select B. To select this B or this AND gate B, we have to put this on. So we put select on. Once we put select on, then it turns on this AND gate and it shows you that B is on. Why? Because select is on, the enable is on, then B is on, meaning that you have chosen this and not this first AND gate. So that's why the output will be 1. If I turn off B, I've turned off B. I've still selected this because the select input is 1. Select input is 1, meaning that here will be 0. So definitely this will be out. So because this is 1, the B input is off, but the enable is on, meaning that it's going to give you a 0, showing us that the one you have selected, which is this AND gate B, is off because B is off. So that's basically what a mux or a multiplexer circuit does. What multiplexer circuit does, it select between which input that you want to choose, then it varies that. So I told you that enable is not a must. You can just connect these using a 2-input AND gate. I also have a 2-input AND gate, only that I have made them to be a 3-input AND gate for me to add the enable. So enable is not important. You can just use the select and the 2 inputs, and then it can work the same. So that's basically what a multiplexer, 2x1 multiplexer circuit performs. And next time we are going to do a 4x1 multiplexer, and just like that we'll be moving on closer in order to make a functional ALU, having the half adder, full adders, having the multiplexers and the flip-flop circuits. So that's it, and I hope you've enjoyed. Hope it's not pretty hard. Please subscribe to Tronic Synergy, share this video to as many people as possible for them to learn how do computers operate. So thank you very much guys for watching. Hope to see you next time. Bye.